Thank you so much, everyone, for joining us today. A very warm welcome to all of you from Food Marketing and Technology magazine. We are so delighted to host you for a business webinar on technological advancements in premium flavor, extract, and concentrate industry with Paulan from Flavour Tech. The idea that Flavour Tech's origins are rooted in discovering ways to desulfide grape juice is kind of a revolution. From there, they built on to build an empire around processing, and they figured out ways to find a plethora of solutions. From preserving the aroma of flavor and liquid tea and coffee, concentrating liquid whey protein at low temperature, and so much more, they really have figured out how to come up with tangible and real time solutions. This session aims to elaborate on the science behind heavy processing, the equipment and tools that work in the market, and also the foundation of how processing in general works. So, we want this session to be about as engaging as it can get. So, please feel free to drop as many questions as possible. We hope you have a great session. Over to Paul.
My name is Paul. I'm from Flavour Tech. It's all a pleasure to meet you. So good morning, good afternoon, good evening, everybody, depending on where you are. So I'll start off by sharing you my screen. So we are here to learn a little bit more about some of the advancements in the areas of premium flavor, extract, and concentrate, and how it benefits our customers, how it differentiates themselves from their competition. So let me start a little bit about myself. I'm the Global Sales Manager for Flavour Tech. Now, Flavour Tech, I'll just go through briefly about who we are and what we do. So Flavour Tech is an Australian company who design and manufacture process technology for thin film distillation, evaporation, and extraction. We are located in Griffith, New South Wales, which is located around about 600 kilometres west of Sydney and about 500 kilometres north of Melbourne. Now, the reason why we are there is that we started off in the wine industry, as Priyash said, that we started off in removing sulfur dioxide from grape juice. And back then, in the 1970s, there were plenty of grape juice around. So they need to store the grape juice. And one way of doing it was to put in preservatives, but during the winemaking process afterwards, you have to remove that sulfur dioxide. And to do that safely without damaging the grape juice was by a spinning cone column. Now, the spinning cone column technology has been around for quite a fair bit, but I'll go through the timelines on that as well. Now, the reason why we look at premium products is that our technologies, which involve spinning cones, equates to short residence time and low temperature focus, which means that the products that you feed into it and go through a distillation and evaporation process means that short residence and low temperatures means that what's important to you in the product, the aroma, the active ingredients in the product aren't damaged through the process. So therefore, our customers can produce a better quality product, better aromas, more active ingredients inside the product, and so differentiate their products from their competitors. As you can see by the photos, this is our manufacturing plant in Griffith where the systems are being built. Now, the industries that we focus on, and these are the 6 key areas we've naturally fallen into. The first one is the coffee and tea industry, where about 60+% of our business is in the area. We are considered, or the SSC is considered the gold standard in terms of aroma capture for the instant coffee production. We have many systems around the world in the coffee and tea manufacturing sectors where they're able to capture the desired aromas from the extracts in the process of making instant coffee. We also have systems in the RTD, ready to drink industry, as well as tea areas as well. The next sector is the dairy industry, where the spinning cone column is used rather than capturing desired aroma. We can remove undesired or undesirable aroma through the process. So in the production of butter, and I'll go through this in a bit more detail in a case study, there is a way to remove those undesirable notes as you concentrate from milk to cream to butter. We also have a technology called the centrotherm evaporator, which is a very unique 1-second evaporation system, which can concentrate milk as you go towards making milk powder, you need a quick yet gentle process of doing that without damaging the milk proteins. Now, the alcoholic beverages sector, we started off in the area of using the spinning cone column. Now, the spinning cone column is used to produce quality no or low alcohol or zero alcohol wine, beer, and cider. Now, I'll just focus on wine. Wine aroma is very, very prone to thermal damage. And so we have to use a way to remove the alcohol with a technique that won't damage the delicate wine aroma. And the spinning cone columns used throughout the world to do that. The next sector is the pharmaceuticals and nutraceuticals industry, where our centrotherm evaporator, which is that 1 second evaporation, is quite crucial in keeping the desired active ingredients, or the active pharmaceutical ingredient, or API for short, intact. And so the pharmaceuticals and nutraceutical companies use our evaporation systems to remove solvent, remove water through post-extraction and concentrate using a very gentle yet efficient process. Flavors and fruit and vegetables can be blended together, where a lot of the flavor manufacturers around the world use our system to capture the natural aroma or the natural water essence from such products as fruits and vegetables, meat, dairy, whatever we can pump through the system, we can capture the natural essence of the product. Some of the examples are apple, bananas, strawberries, mango, those kind of flavors we can get from the spinning cone column. We also, as I mentioned before, have the evaporator to concentrate the juices without damaging the aroma, the color, or anything that's important to the product. Now, let's jump into the key products. And I mentioned the spinning cone column and the centrotherm evaporator. We also have what we call the integrated extraction system, where we combine these technologies together to produce an online automated system for the coffee and tea industry. So let me dive into the spinning cone column. Now, audience members, you may have heard about the spinning cone column. It's a product that's been around, or the technology has been around since the 1930s. The first mention of the spinning cone column was in literature that was describing a technique to separate water from heavy water using spinning cone technology. But it wasn't until the 1960s when Dr. Casimir looked at ways to separate sulfur dioxide, or removing the volatiles from juice, because juice is quite prone to heat damage. There's many distillation techniques out there. There's many vacuum distillation techniques out there. There's pack columns, there's plate columns, there's bubble caps, and so forth out there. But what's unique to the spinning cone column is that it's quite an efficient, fast distillation process that can handle clear liquids, and more uniquely, viscous products or slurries. And I'll go through that in a bit more detail, what you can get from clear liquids compared to viscous products or slurries as well. So I can compare the three for you. Now, some of the examples of clear liquids are juices and extracts. Viscous products are fruit purees. Slurries, for example, are roasted coffee beans and tea leaves. Now, Flavour Tech liked the spinning cone column so much back in the 1970s, when it was being developed by a research organization called CSIRO, a Commonwealth research organization, that they bought the technology, and now we manufacture this at the Griffith premise. Now, the spinning cone column is a vertical stainless steel body with a central rotating shaft. It's not going very fast, as you can see. It's 350 RPM. Now, it's not a centrifuge. Centrifuges run at around thousands, 2000s or more RPMs. Some of the literature, or you might hear people talking about it, as that it acts as a centrifuge where it spins out the different compounds. Well, that is incorrect. The rotation of the cones is really designed only to produce a thin film on the cone itself. And I'll go through why the thin film is required. But as you can see down here, the central rotating shaft only spins at low RPMs. So we have the central rotating shaft, and we have on this shaft, we have spinning cone attached to it. And then on the directly below that is a stationary cone. In this picture here, we have cut away. So it actually wraps around the whole rotating shaft, but for this diagram, we just cut that away so you can see what's happening inside there. On the spinning cone, there are fins. These fins, while turning, produces a vortex, which helps the stripping or the capture or removing of the volatiles from the product feed material. Now, as you can see down here, there are stationary cones and spinning cones inside there. And we have alternating stationary cones and spinning cones, as you can see down here. There's 20 sets of each. Okay, so as the product comes in, it then gets heated up to a certain temperature, enters the top of the column, and then falls onto the first stationary cone, as you can see on a thin film. It falls under gravity. Now, it produces a thin film, roughly about 1 millimeter thin film thickness. Hits the spinning cone directly underneath that, where it's spinning and it's flung upwards and outwards in a thin film of about 1 millimeter. Hits the wall and comes back down again. Now, it alternates down the column. So we have the stationary cone, spinning cone, stationary cone, spinning cone, as you can see down here. So what we see is a thin turbulent films. The turbulence compared to laminar flow, or turbulent films compared to laminar films, is that turbulent allows a better mass transfer to occur. So a better stripping process or distillation process happening through the spinning cones. There's a long path length because the liquid has to pass down those stationary and spinning cones up and down through the columns. It takes a long path length. Low hold up volume. Now, quite an important part is the short residence time. The residence time is less than 25 seconds. So it enters the top of the column and it goes to the bottom in less than 25 seconds. So it's very, very quick. Now, as I mentioned before, we can handle viscous material and suspended solids through that. So we can handle purees, we can handle suspended solids, we can handle slurries through the system. No other distillation column. If you got pack columns through the system, for example, packing in the columns, you cannot put solids through the product because it will contaminate the packing and then you'll have contamination in your product. So the product enters, as you can see, the top of the column, and then it falls through the column itself and is discharged from the bottom. And at the same time, we have stripping steam coming through the bottom and enters counter current flow to the product. So in this picture, we have the steam or the volatiles moving in the color of light blue here, and the product going down and up and down the column is shown in green. So we have a counter current steam travel that is aided by the fins to help in the stripping process. Stripping means that we're stripping the volatiles out of the product feed material. Now we control the temperature, but controlling the vacuum pressure. We've got a big vacuum pump inside there, so we can control the temperature to close to ambient to 100 degrees Celsius, depending on what you're trying to strip out and what product you're feeding into the column. So we have here, as I mentioned before, the product entering to a certain temperature to the spinning cone column. It then falls down the column in less than 25 seconds and then is discharged from the bottom. Stripping steam enters counter current flow up the column, where the volatiles are then stripped and then is condensed through a condenser and captured and stored. That is what we call our aqueous essence, or we capture essential oils from the product material. Now, when you have a material that you can compare, for example, as I mentioned, juices or extracts, when you capture aroma from, say, let's just mention, say, coffee extract. So in the coffee industry, the SSC or spinning cone columns used to capture the aroma from the coffee extract. After the brewing process, a high temperature process, the coffee extract then goes through the spinning cone column where it's used to capture the aroma. Now, when you compare that to the actual aroma from the roasted beans itself, it's quite different. The aroma from the roasted beans is more representative of the roasted beans. The roasting ground notes are still present, while the extract is not. Now, if you also compare, say, aroma from juice, so we have apple juice, for example. If you compare the aroma from apple juice compared to aroma from apple solids, apple puree, it is completely different. We have a more representative aroma from the whole apple itself compared to the juice. There's a lot more aroma in the from the solids itself. And that's why we thought, how do we improve or increase the aroma profile from products like coffee, tea, and fruits and vegetables through the product? Our engineers thought about this and designed a unique and novel system called the slurry preparation module, where we actually mill the product under a blanket of cold water. Now, why do we use cold water? Why do we mill on the blanket of cold water? So what happens to it is that when you stand next to a barista who's milling coffee beans, roasted coffee beans, you can smell the aroma straight away into your nose. It's quite a lovely smell. It's got the top notes of the roast and ground flavors, which is then leaving the coffee beans and then entering into the atmosphere. We call that a loss. Those lovely top notes that are quite desirable to the consumer are lost into the atmosphere. We always ask, why are we losing it? Why not capture it? That's why we mill under a blanket of cold water. Those lovely top notes and the slurry then enters, and I'll go through this process here. We have the product entering here, where we add cold water to the mill, and we cold mill the processing water to capture the top notes, and then the top notes and the slurry all enter the spinning cone column, where we capture all the aroma. Now, that is completely unique to Flavourtech in being able to capture all the lovely notes, including the top notes of the product feed material. Now, we've done coffee, we've done tea, we've also done many, many different fruits. That's why a lot of flavor companies love this setup, because they can add fruit purees, fruit slurries into the system to get a more representative flavor profile from the product itself. There's also a terminology from the name fruit or from the name source. That's what the flavor companies do with the spinning cone columns, produce an essence, a water essence from the name fruit. Now, you're thinking about what kind of viscosities, what kind of things can you put through the system? So as you can see down here in this example, we have green tea discharge. It's a 10% vapor weight of green tea slurry being discharged from the bottom of the spinning cone column. As you can see by this photo, it is quite a viscous product. We always say that as long as you can pump it, as long as we can pump it through the pipes in the system, we can capture the aroma. The spinning cone column photo here is an example of a customer site where you have a dual column system running in parallel to capture the aroma, in this case, fruit. So the benefits of the SCC is that the flavors concentrate without the need for further rectification. Now, there's a lot of aroma capture devices out there. You may have seen them already, but they do come out in a worse state of the aroma profile, because it has a high temperature, high residence time, and also it comes quite diluted. So they may need further rectification after that. So you lose or damage more aroma through the process. Our spinning cone columns are very quick, very gentle, short residence times, low operating temperatures, so the fragile volatile compounds are recovered intact. The flavor profiles can be controlled by controlling some variables inside the system. We can capture wanted aroma, but we can also remove undesirable or unwanted aroma as well. Now, I'll give you some examples of the system variables that we can control to get different aromas, and what we can do for the temperatures depending on what product we feed in. This particular, diagram here shows you what products we feed in and what temperatures. We find that coffee through the system can be run at 100 degrees Celsius. Coffee aroma is quite robust. We're able to capture the aroma from coffee at 100 degrees Celsius. Orange, we have to go lower. It's more prone to damage, more prone to thermal damage. And so we reduce the temperature by increasing the vacuum through the system. And then we go to the more delicate flavors like passion fruit, mango, bananas, those kind of more exotic flavors that we have to go to lower temperatures, roughly around about 50 degrees Celsius. We ran strawberries recently with strawberry puree. We're able to get lovely strawberry puree notes through the system, but we ran it at 50 degrees Celsius. Now we compare that to strawberry juice, and you get different aroma profiles from the puree compared to the juice itself. Now, I mentioned before that wine aroma is quite delicate. There might be people in the audience who are familiar with the winemaking process, but winemakers keep everything at low temperatures. Everything's done at cold temperatures. Some of the grapes are picked at nighttime to reduce the temperatures at all times. Now, when the winemakers are asked to remove the alcohol from wine to make a no or low or zero alcohol product, they get quite shocked because they have to use some kind of vacuum distillation system that requires a thermal input, some kind of temperature to the wine itself. But the spinning cone column is the most gentle vacuum distillation system out there. Again, 25-second residence time under vacuum, low temperatures, about 30 to 35 degrees Celsius for wine, means that the wine aroma we capture is intact. We store that, and then we remove the alcohol, and then we put the wine aroma back in again. So many of the no or low alcohol, zero alcohol wines you see in the market today have been put through the spinning cone column. The next example here is about changing the temperature of the column, but by doing so, you can change the characteristics, the aroma characteristics from the same raw material. Now, green tea, this was a customer that is doing this now where with the same raw material, this green tea that they have, they feed the green tea solids itself in a slurry at around about 55 to 60 degrees Celsius. They find that from this temperature of the column, the green tea aroma, these lovely matcha seaweed characteristics are captured and produced. And this is quite desired in the Japanese and Korean markets. I don't know if you ever gone to one of those cafes or coffee cafes where they have this green tea matcha tea. It's quite a strong, lovely seaweedy characteristics. That's very similar to that. But in Southeast Asia, for example, like in Indonesia, hay grassy characters of stronger green tea flavors are desired simply by raising the column temperature to 75 degrees, by having the same raw material being fed, allows you to get different characteristics from the same raw material. So the spinning cone column is quite good at providing different aroma profiles from the same raw materials by changing some variables like the column temperature, how much steam we use. It's another example to get different aroma profiles to suit your customer. Now, this example is about removing undesirable. Now, we talked about capturing wanted or desired flavors. Now, what about removing undesirable notes? Many of the dairy cows in the Northern Hemisphere are fed on grains. So we get a consistent flavor from that because a lot of the feed material to the cows then pass on to the milk. And as you go from milk to cream to butter, the final is the butter production, you get a concentration of flavors. Now, in the Northern Hemisphere, they're mainly fed on grains, so you get a consistent flavor coming through. But in the Southern Hemisphere, most of the dairy cows are fed on grass. And with seasonal changes, you get grass, you get weeds, you get flowers through the seasons. And as you go from milk to cream to butter, you concentrate those flavors and you get a variation in aroma from the butter. Consumers don't want the variation of the product, so they want a consistent flavor profile. So there's many dairy companies or butter production facilities in the Southern Hemisphere that have spinning cone columns, removing undesirable, what we call cow flavors from cream on the way for butter production. Now, in this picture here is actually of a site where they have 3 columns running in parallel, each column running 9,000 liters per hour of cream through the system to deodorize cream on the way to butter production. Our other technology still utilizing the spinning cones is the centrotherm evaporator. Now, the centrotherm evaporator has spinning cones as well, but the product is sprayed underneath, and the spinning cones produce a thin film of 0.1 millimeters. It has an evaporation temperature of 50 degrees Celsius, a steam temperature of 120 degrees Celsius, with a delta T, a difference in temperature of 70 degrees Celsius. Now, we can control the two by the vacuum as well. But the unique feature of this is the evaporation time, 1 second evaporation time. So it is quite quick and a gentle process. Now, if you compare this with other evaporators like tubular, rising, falling film, we have different evaporations represented by different colors here. But in the red there, the Flavourtech centrotherm evaporator has a low residence time of 50 degrees Celsius and also 1 second evaporation, which means that whatever you feed in, the active ingredients inside it are protected and not damaged through the system. A very gentle yet effective evaporator. So this is an example of the centrotherm evaporator at a site there to concentrate to high concentration levels using spinning cone technology. Now, there's different evaporation models, but you rely on this to evaporate delicate heat-sensitive products or viscous products as well. We have honey manufacturers that remove excess water from honey without damaging the product. We also have many companies that use it as a final evaporation stage. And what that means is that as the product becomes more concentrated, more viscous, it is more prone to damage or thermal damage through the system. So they go from a falling film, a rising film evaporator, and then jump into the centrotherm evaporator, where it is quite sensitive to heat. So the centrotherm is very quick, very gentle, and it's able to evaporate or concentrate without damage to the product. Some of the examples here, as you can see in this list, there's a lot of active ingredients from pharmaceuticals, nutraceuticals being used to concentrate for solvent removal without damaging the valuable ingredients inside the product. We also have these products, as you can see here, that are used through the centrotherm to maintain the quality. So this is the way that our customers can differentiate their products by having a more concentrated active ingredient through the product. I'll give you an example. The gin and tonic market was booming around about 3 to 5 years ago in England and all over Europe. But gin and tonic is a colorless product. It's in nightclubs, in bars, in restaurants. Some of them considered, yes, it was tasty, but it was quite dull because it was colorless. So there was a move towards adding some kind of color agent inside there to produce a more vibrant color. And one of them was the color from bright red oranges, blood oranges, I should say. So our customer came along and using their own evaporator, they found that the color had changed from red to this bright red to a darker color. This was because of the anthocyanin, a flavonoid that polymerizes to form a long chain, which darkens the color. So when you add that to gin and tonic, it did not produce that vibrant pink color as you see here in this picture. But through the centrotherm evaporator, this color is still maintained. They ran a GCMS, an analytical analysis on that product, and found that there was no damage to the anthocyanin whatsoever. So it was able to concentrate this product without damage to the active ingredient, or what was more important to them, which was the anthocyanin to produce that bright color. When you combine the technologies together, what we have is that we have what we call an integrated extraction system, or IES for short. These systems allow an inline automated continuous process for the coffee and tea industry to produce cold brew, ready to drink beverages, as well as instant coffee or tea products. This is an example of one of our customers that have systems that are inline. The first one is a slurry prep system, a spinning cone column, a solid separation decanter, and then we have the centrotherm evaporator, all in a line in a very small manufacturing area. Now, I'll jump into and concentrate into the soluble coffee industry, where the soluble coffee manufacturing hasn't changed for close to a century. It really is there to maximize yield at the expense of flavor. If you really go after yield, you will at the expense of flavor, you will lose flavor, unfortunately, because you're trying to achieve something that at high temperatures to get as much solids out of the beans. You're trying to dissolve as much solids from the beans to produce a soluble product. But then in the process, you lose a lot of the aroma, or you damage the aroma through the process. So you see here in this stepwise pictorial, hydrolysis high temperatures, 180, 109 degrees Celsius through many high temperature cells, produce an extract. There may be a flavor capture device, and then you go through to make soluble coffee at the end. Now, this is a bit more of a diagram where it shows you the process where a lot of the aroma depicted here in those orange yellow fumes are lost in the high temperature process. In the extraction cell here, evaporator is another area where there's temperature, you lose the aroma, and the spray dryer as well. So there's a lot of processes, or a lot of areas where the flavors are lost. So there's a lot of flavors generated by the roasted beans, the beautiful RNG notes. There's say 100 notes produced, just an example. By the time you reach the soluble product at the end, there's about 10 flavor notes. So you actually lose a lot of flavor into the atmosphere. So what we thought about was, how do we improve this process, which has been around for a century? How do we improve this process where we can capture more of the desirable roast and ground flavors, and then pass it on to the final product, which is the instant or soluble coffee? We thought about this, and we thought, why not capture all the aroma from the roasted beans themselves using our slurry mill process? So we capture all the aroma from the roasted beans, including all those top notes, the single origin notes, then store those aroma at low temperatures, go through a hydrolysis step, much quicker though, only 20 minutes, and then produce the extract, go through the clarification process, go through a gentle concentration using our centrotherm 1-second evaporation system without damaging the extract. Then to the concentrate, add back the aroma before spray drying. So this is the process here. So we have the roaster producing the lovely roasted beans with the roast and ground flavors, go through a wet mill process where we add water to produce a blanket of coal, or blanket where the aroma is captured. This then enters the spinning cone column where we capture the flavor. The flavor here is represented in green and stored at 4 degrees Celsius. You continue on to your high temperature process, this time in only 20 minutes continuously. And then you go through the clarification process through our unique 1-second evaporators, not to damage the extract in any way. And then just before spray drying, add that flavor back in again. Now you have concentrated flavor and you have concentrated extract together, spray dried. Those two are close to each other. So when you spray dry, the extract compounds bind the aroma compounds and fall out at a much higher rate in terms of flavor capture. So your flavor profile in the instant coffee is much higher compared to other extraction processes. So if you want to run some of your samples through our product, if you're curious, if you want to run your fruit, if you want to run your coffee or tea or other products through a system, yes, we can do that. We have pilot plants in Griffith, New South Wales, Australia. We have another one at Wageningen University in the Netherlands. We also have one in the USA at Kansas City, run by our official distributor, by a company called Scan American Corporation, where we can prove the concept to you. And you're more than welcome to come across, because I know when you're there, you're able to smell and taste the product coming out. You'll get that aha moment to say, wow, okay, that's what Paul's talking about. It's a high aroma profile. It's much cleaner and much more concentrated. So as I mentioned before, our processes, as you can see down here, are ways where our customers can differentiate their products, having a product that's fed through to produce a much higher quality product in terms of flavor, in terms of active ingredients as well. So I thank you for your time, and I'll look forward to meeting up with you sometime in the near future, face to face.
So again, thank you so much, Mr. Paul, for taking time out and for breaking down a rather complex topic with so much insight and clarity. Thank you so much. And thank you all of you for carving out time to attend this session. Our webinars really are an extension of our food marketing and technology magazine. So we have technical articles, advertisements, all the relevant updates on the industry on a monthly basis. So if you want to know more about us or you want to reach out to us, contribute, you can take a screenshot of the slide and you can reach out to us. Thank you so much for joining us. Have a great day. Thank you so much.